Hello and welcome back to my tutorial series, Unity 3D for Beginners. In part 1, I talk about installing the Unity editor and Visual Studio, along with creating a basic scene in Unity and getting familiar with the Unity editor. If you haven't watched part 1, you can check it out in the description below. In the second part, we're going to be talking about making a basic movement script for our player object. By the end of this tutorial, you'll be able to move your player forward, back, left, and right, along with any diagonal combination. You'll also learn some basic C# programming along the way. Make sure to subscribe for more educational content, and let's get into it. In order to control the player, we'll have to create a player movement C# script. Now there's two ways you can do this. The first is by right-clicking in the project window, going to Create, and clicking C# script. We can then name it Player Movement. However, when creating it with this method, you'll have to drag the script onto the object you'd like to apply it to in the scene. The other way you can create a script is by clicking on the game object in the hierarchy, in this case player, going to Add Component, and searching in the name of the script. That will allow you to create a new script with the name that you searched. Click Create and Add, and the script will automatically be added to the game object. The downside to this method is that it will be saved in your base assets folder rather than a location of your choosing. Also note that C# scripts work as a type of component since they can be applied to game objects. To check that Visual Studio is synced with Unity, you can click on the Edit tab and go to Preferences. There, click on External Tools and make sure that the External Script Editor is your version of Visual Studio. After the script has been created, you can double-click on it either in the Inspector or Project window to open it in Visual Studio. Once the script is loaded, you'll be met with this blank template script. Now, assuming you have no prior programming experience, I'll try to explain each element of the script in its simplest terms. At the top of the script, you have your namespace directives. You can declare these directives with the keyword using. These namespaces are usually tied to whatever libraries you have imported into your project, such as the Unity engine. A lot of these are built into Unity and contain some commonly used functions. Next is the class declaration. That essentially defines the main class for the script. A class typically represents an object, which has methods or functions, and attributes or variables. Attributes can be words, numbers, or other types of data that can describe or provide information about the class. Methods essentially describe what the class or object can do. Most classes typically inherit from monobehavior. Two commonly used methods for monobehavior that are included in this script template are start and update. The start method is called once the script is first enabled. This is typically where you'll initialize variables or references, or set starting values. The update method is called once per frame. This is where you'll be performing a lot of your calculations. The sentences written in green are comments denoted by the double slash that precedes them. A comment is a line of code that is not read or processed by the compiler, meaning it won't affect the behavior of your program. It's common practice to write comments in your script to help people read it and understand how your program works. Now let's start writing our script. First, we'll define the player's move speed by writing public float move speed. Declaring a variable as public allows it to be edited in the Unity editor and accessed by other scripts. The keyword float means that move speed is of data type float or floating point number. You can think of it as a number with a decimal point, like 3.14. Next, we'll define a vector 3 called move, which will be used to interpret the player's input as a 3D vector. Vector 3 is a data type that's built into Unity as 3 floats for x, y, and z. To obtain input from the keyboard, we can use the function input.getAxisRaw. That will allow us to obtain left and right input from the player, left being -1 and right being +1. Left and right are associated with the horizontal axis, so we'll have to pass in the string horizontal. String is the data type used to represent words, which is indicated using surrounding quotation marks. However, this function will only give us a number. To turn it into a vector, we can multiply it by vector3.right, which is the unit vector that points to the right. To actually make the player move, we'll be taking the player's position and adding a scaled version of this vector to it. We can write transform.position plus equals to add to it the input move vector times our previously defined move speed times time.delta time. Time.delta time is the amount of time it takes for a frame to render. Multiplying by it will assure that the player moves at the same speed regardless of the game's frame rate, since the method update is called every frame. To recap, we first define the player's speed. then obtain the player's input, and use that speed to calculate how much we should move the player each frame. Press Ctrl S to save the script, and let's go back to the Unity editor. If we press play, and press the left and right arrows on our keyboard, or A and D, we still can't move the player. That's because if we go into the inspector and scroll down to our player script, the player speed is still set to 0. If we change this value to a positive number like 10, we can finally move our player left and right. If we press play again to exit play mode, notice that our move speed is set back to 0. Remember that any changes you make in play mode aren't saved. Now if we go back into our script, we can write in the line above our move speed declaration, in brackets, range from 0 to 10F. This allows us to use a slider in the editor to set our move speed to prevent us from setting negative or super high values. You can choose the minimum and maximum to be whatever you'd like, but for my own convenience, I set the range to be from 0 to 10. Notice the F after the 10 to indicate that it is a float value. If we save our script and go back to the editor, you can see that I can now set the value for move speed with the slider. If I press play, I can actually test it during play mode to find a value for the player move speed that I like. I can set a lower value for slower movement or a higher value for faster movement. As of now, we can only move left and right, so let's make our player be able to move forward and backward. We can go back to our player script and add to our movement vector input.getAxisRaw, but in the vertical axis, and multiply it by vector3.forward. Note that this is still done in one single statement. Every statement in C# is ended with a semicolon. So while this statement still takes up 2 lines, it has a single semicolon at the end of the statement. If you save the script and press play, we can move in any of the 8 directions along our plane: forward, backward, left, right, and any diagonal combination. So now we have some horizontal movement for our player, but we don't have vertical movement. So make sure to click the notification bell for my next upload, where I'll talk about how to make our player jump. Comment your thoughts below, and I'll see you in the next video.